A bag consists of two $1 coins and six slugs. And a slug basically looks and feels identical to a coin, but it's of no value whatsoever. The game consists of reaching into the bag and drawing a coin, and you get to keep whatever the value is. If you keep the slug, you don't get anything. If you keep the dollar coin, then you get basically a dollar. What we're trying to do is determine a fair price for playing the game, something you have to pay in order to play the game. So in other words, we're looking for something in which you break even and in which the expected value is going to actually end up being zero. Okay, so we've got to think about how to calculate expected value. In order to calculate expected value, we're taking the amount of the payout, in this case it's $1, multiplying that by the probability of getting that payout. Okay, so if we're going to receive a dollar, we multiply that by the probability of actually getting that dollar. So there are $2 in there and six slugs. So there are 8 total coins in there, of which 2 of them are a dollar. So our probability of actually getting the dollar would be 2/8. The probability of getting a slug would be 6/8. And the expected payout on that is 0. 0 times 6/8 would just be 0. So we don't really need to worry about that. Now, the other thing that we need to worry about here is the cost to actually play the game. That's what we're trying to determine. So then what we're going to do is we're going to subtract the amount that it's going to cost to actually do the game. So we subtract the cost, and our goal here is to have our expected value equal 0. Okay, now what we've got to do is calculate this cost, and this is kind of like an algebraic equation here. So if we go 1 times 2/8, 2/8 is 1/4, which is 0.25. So 0.25 minus the cost is going to equal 0. So it's kind of a little bit different with this word cost in here. If you can think of it like an x, 0.25 minus x, because we don't know what the x is, that's what we're trying to determine here, equals 0, what would we do? Well, I've got a negative x here, and I know it needs to equal a positive x, so I might as well just move my x onto the other side. So if I take it and I move my x onto the other side, then we're going to treat it the same way here. Okay, we've got this negative cost, so we're going to move our cost over to the other side. We're going to add cost to both sides. And if we add the cost to both sides, then we find out that the cost should equal 0.25. Okay, so basically we should be charging a quarter every time in order to get our expected value to be 0.